All right. This week we have learned a lot about probability. We've learned about it in experiments, we've learned about it in real world situations. Well, now we're going to try a new level of probability where we're going to tie in experimental probability, where we are going to perform some experiments and talk about relative frequency. So this way you can further that understanding. So let's do this experiment together. We're going to roll this dice. You're going to roll it. You're going to tally how many times you roll each number, and then we're going to calculate relative frequency together. Let's start. We're going to do this 50 times. 2, 4, 6, 4.
Oh no. 2. 5. 6.
6 and 6.
8. 9. Oh, finally got a 1. 13, 14, 15, 16, 23. Oh, 26. 27. 28. 30. 32. 33. This dice does not like the number 5. 35. 36. Oh no. 37. 44. 45. 46. 49. 50.
Okay, so now here at the bottom of your section, I want you to tally up how many you had of each number. Well, yeah.
So this would be 10.
Mm-hmm. Okay, so if you added all these up together, what would you get? 50. All right, so now we're going to put all of these over the whole number. So this is the number of favorable outcomes over the number of possible outcomes. So for relative frequency, we're going to put the total number of favorable outcomes over the total number of possible outcomes. Just like we're going to create a fraction. See what I mean? So we're going to do like 4 over 50, 11 over 50. So you want to go ahead and do that? And we'll calculate them. Yeah, you can do it right there. Okay, so now here's what we have to do to calculate the probability. So 4 out of 50, we're going to change it to where it's out of 100. So how would we do that? We're going to set up a proportion. Okay.
Okay.
So here's what we're going to do. We're going to do 4 over 50. Let's blank over 100. So when we're doing that, here's how we figure it out. What's 50 times what equals 100?
50 times 2.
Okay, so what do we have to do to the numerator?
Multiply by 2.
Let's do it. So now let's change this to a decimal. What does that equal as a decimal? Perfect. Now let's do this for each one.
Oh boy.
So we're going to just set up a bunch of proportions because we're trying to calculate relative frequency. We're doing great.
How many times 2 was first? 32.
So now put all those into decimals.
Oh.
Okay, so here's how we're going to explain experimental probability. So theoretically, how many numbers do we have on a dice?
6.
Okay, so what do you believe that what was the probability of getting a 1?
1 out of 6.
1 out of 6. So do you feel like that any of these probabilities line up to what a theoretical probability of a dice would be?
No.
No. And why is that?
Because they would all be the same.
Right. So because we didn't have the most fair dice, we ended up having a lot more come out with the number 6 than we did, say, with the number 5, right? So theoretically, we would all had 1 6, but instead, now, because based off experimental probability, we got to calculate the relative frequency based off of what, like we did in the experiment. So that kind of brings like a whole new perspective into probability. So now we're going to transition. Here's your next assignment. So today we're going to be doing a puzzle. So each category, you're going to have 6 pieces. You're going to have one for hurricanes, 6 pieces for hurricanes, 6 pieces for tornadoes, and 6 pieces for earthquakes. So your job is to read each question, and each question is based off the category, and figure out where these pieces are to go into what boxes. So when you figure out which one it goes into, you're just going to tape it down for me. So let's count 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we got 18, and we got 18 boxes. So place the correct piece of paper into the correct category based on the questions. So each piece of paper has a probability or negative impact or preservation effort or human modification to correspond with the question based on the specific natural disaster. So question 1 says, what region would have a high probability to being affected by hurricanes, and what kind of negative impacts could that natural disaster have on this region? And what kind of positive human modifications or preservation efforts can lessen this impact? Do you have any questions?
No.
Do you understand the terms human modifications and preservation efforts?
What is preservation?
So preservation efforts is talking about how ways that we can preserve, say our home from a natural disaster, ways we can lessen the impact, kind of like prevent preventing a lot of damage to come to our personal possessions.
Oh.
If you have a question about any of these terms, just let me know and I'll be happy to answer them.
What is this one?
So replace rigid plumbing supply lines with flexible braided lines. That's kind of like replacing the plumbing with sturdier material so it won't like fall apart. And that one's probably best to save till last until you figure out some of these other ones. So kind of think about what would you do in a hurricane? Let's think about this. Would you practice seeking shelter in secure buildings during a hurricane?
No, that and tornado.
What do you see some people on TV that do to their houses when it's during a hurricane?
Right.
If you believe it, yeah, go for it. I would do it in a hurricane.
Oh, let's see.
If they're all similar, they know exactly where they go. Oops. I'm good. As long as I can read it. So now we're going into tornadoes. So what do you know about tornadoes?
They're scary.
Yeah. Always not.
Really fast.
Really fast.
And windy.
Let's bring them all together so you can kind of look at them here. So what do you got left? You're looking for a negative impact. So what's a negative impact of a tornado?
Thunderstorm that extends to the ground and warm, cold air. Masses clutch.
You do. That was smart. Now you just gotta put the rest of the pieces exactly where you think they would fit. Excellent. Now let's review what we did. Okay, so the first question talks about what high probability to being affected by, what region would have a high probability to being affected by hurricanes, and what kind of negative impacts could that natural disaster have on this region, and what kind of positive human modifications or preservation efforts can lessen its impact. So for the region, you chose the East Coast region, which is correct. The negative impact of a hurricane would definitely be flooding and also a storm surge. So for human modifications and preservation efforts, you chose distributing sandbags and boarding up homes, which is very true. Like in the sand dunes, they would distribute sandbags and like they board up their windows and different things to kind of like keep from breaking the glass so it won't bring as much water into the home. So the probability is between 0.5 and 1 that this natural disaster will occur in this region. For the probability, if we know that there's a high probability, that means the probability is going to be between 0.5 and 1. Because if it's less than 0.5, that means it has a low probability. But we both know by experiences lately, you know of some hurricanes we've had lately?
Florence.
Florence, is there any more?
Michael.
Yes, both of those have hit us hard lately. So the second question is, what region would have a high probability to being affected by tornadoes? And what kind of negative impacts could that natural disaster have on this region? And what kind of positive human modifications or preservation efforts can lessen this impact? So for tornadoes, you chose the Midwest region, which is true. Do you know a place in the Midwest that is known for its tornadoes?
Indiana and Kentucky.
What about, have you ever watched The Wizard of Oz?
Kansas.
Yeah, Kansas. So like Tornado Alley, a lot of places that are more dry and have open fields and plains. And so the negative impact of a tornado would be rapid destruction of homes through high wind speeds on dry plains. And another one would be thunderstorms that extend to the ground when warm and cold air masses clash. So it's like a big funnel of air coming down. It sounds like a train coming at you. So what would you do to modify your home or to preserve your home in that kind of effort? You would tie down loose objects outside or bring them inside and stay away from windows. And then also stuff that we do at school, like we practice tornado drills, so we practice seeking shelter in a secure building in a secure area. So the probability of a tornado happening in the Midwest region is high. The probability is between 0.5 and 1 that it will occur. So now, the last question. What region would have a high probability to being affected by earthquakes? What kind of negative impacts could that natural disaster have on this region? And what kind of positive human modifications or preservation efforts can lessen this impact? So you chose the West Coast region, which is true. Is there a place you know of?
California.
California? Do you know what place in California that has a lot of earthquakes? No? So like anything along fault lines, which are places where tectonic plates shift a lot, causes earthquakes, like the San Andreas Fault. But you have, what earthquakes can create? Some of them can create mudslides, and some of them can also trigger volcanic eruptions, which is really scary. So for human modification, a good thing that is practiced is like secure furniture in the home to the floor and replace rigid plumbing supply lines with flexible braided cable lines. So the probability of an earthquake happening in the West Coast region is high because it's between 0.5 and 1, so that this natural disaster will occur in this area. Do you remember any earthquakes that have happened in the past few years? Anywhere?
Nope.
So I think about like Haiti, where that earthquake happened, or like Japan, or there was a small one a few years back in Virginia. So they can happen anywhere, but we know for a fact that based off historical data, that earthquakes do happen often at the West Coast region. So now we're going to transition. We are going to move on to more probability.
Yay!
So we're going to be talking about a standard deck of cards. So a standard deck of cards consists of 52 cards. So what is 52 cards in this situation going to be?
The frequency.
That's right. So the 52 cards is going to be our total number of possible outcomes.
Possible outcomes.
So it's going to be our denominator. So there are 4 suits: black, spades, red hearts, red diamonds, and black clubs. Each suit contains 13 cards. You have the ace, you have the number 2, 3, 4, 5, 6, 7, 8, 9, and 10. You have jacks, you have queens, and you have kings. So, knowing this information, let's answer the following questions on your guided sheet. So, what is the probability that you would choose a card with a red shape from the deck?
No, wait, no, there's two.
Yeah, so let's think about this. So if we know what our denominator is, so let's go ahead and start with that.
Out of 52.
So we'll start with that, out of 52. So let's think. How many colors are in the deck? So you know there's only 2 colors in the deck?
Yes.
Which are those?
Black and
Okay.
26.
So is that your answer? 26?
Out of 52.
So 26 out of 52 cards will have a red shape from the deck. Perfect. So what is the probability that you will choose a card from the diamond suit from the deck? How are we going to figure this one out?
There's 4 shapes. So 52 divided by 4. 13 out of 52.
Okay. All right. What is the probability that you will choose a card that is a red spade from the deck?
So
I want you to read it very carefully. What is the probability that you will choose a card that is a red spade from the deck?
there's 13. Wait, there's 13 spades. But half of them. How is that possible?
Look at it. Is it possible to find a red spade in the deck?
No.
What's the probability of finding one?
0 out of 52.
What is the probability that you would choose a card with the number 7 from the deck?
4 out of 52.
Okay.
Right.
Yeah. Do you know if that can be reduced?
2 out of 113.
No, right beside it. Just to show me that you know how to simplify your fractions. There we go. So what is the probability that you would choose a red card with the number 5 from the deck?
2 out of 52.
Can that be reduced?
Yeah.
Perfect. So 2 out of 52 can reduce down to 1 out of 26. So what is the probability that you would choose a card with a face from the deck? You want to tell me how you got that?
There's Jack, Queen, and King, and there's 4 sets of each. So 4 times 3. 4. I confused myself.
Well, I think you can put 4 plus. 4. Which would be
12.
perfect. So you got it right. Can it be reduced? Great. So 12 out of 52 can be reduced to 3 out of 13. So what is the probability that you will choose a card with an ace from the deck?
4 out of 52.
Perfect. So what is the probability that you will choose a card with a black shape from the deck?
trying to say. A flat shape. Yeah.
Can that be reduced? So what is the probability that you would choose a card with a number on it from the deck?
Does ace count as a number?
Does it have a number on it?
No.
We'll write it out. So let's think about it. So if we have, how many numbers do we have? 9. So how many colors, let's think about what's probability that choose a card with a number on it. So how many different numbers, how many different colors would we have? So we know how many numbers we have. Then we have 4 suits that it could be.
So times 4.
What would that be?
36.
Can that be reduced?
Oh gosh. Yeah, I think so.
Just think about it. What goes into 36 that also goes into 52?
4.
Strong. So 36 divided by 4 is. You did it down there.
9.
Yeah. 52 divided by 4 is. You did that
13.
All right, last one. What is the probability that you will choose a card without a number on it from the deck?
Mm. 16.
Want to show me how you got that?
There. Ace. Jack. Queen. King. And so there's 4 different suits. So times 4.
All right, can that be reduced?
Yes.
Perfect. Check how long you've been recording.
I don't know.
Pause.